Okay, yeah, here's a nice one. So the series, oh my bad, series starting at k equals 5, so starting at 5, that goes on to infinity, 5 over k ln k squared. Now your interval for this, oh yeah, you gotta remember, your f of x function will mimic your series, and your x will mimic your k. Therefore, your k will be greater than or equal to 5. That'll be your interval. Okay, step 1. Is it continuous, positive, and non-increasing? Increasing. Okay, let's see. Is it continuous? Let's just plug in the number 5. 5 over 5 times ln 5 squared. This will give you a positive number, because if you were to put anything right here into natural logarithm, it should give you a positive number. Plus, it's also squared right there, so whatever's inside that square, regardless if it's a natural logarithm or not, it'll be positive. So this is positive, therefore, oh no, not continuous. Therefore, it is positive. Okay, now continuous. Now we just plug in the first number in our interval, which is just 5, which is what we've been doing. Oh, sorry, I didn't mean to take that away. So yeah, we just plug in the same interval. 5 ln 5 squared. Is it continuous? This gives you a number that's not infinity and that's not negative, so it is continuous. Is it non-increasing? Okay, let's see. Fx 5k ln k squared. Okay, here we can just take the shortcut. Since the top is just a constant, but the bottom is a variable, and the variable keeps increasing, the denominator will keep increasing, and the numerator stays fixed. This means that the overall function will be decreasing. So we can just, yeah, let me just not reset. So yeah, the overall function would be decreasing, meaning non-increasing. Therefore, that also checks out. So we do the integral, starting at 5 to infinity, 5x ln x squared. Now let me see how I solve this. Okay, perfect. So you can say that, oh, hold on, we gotta first use the limit. So limit as b approaches infinity, the integral b to the 5, from 5 to b, we can take out the 5 because it's just a constant. So it'll be 1 over x ln x squared dx. And then we can let u equal ln x, and then du will equal 1 over x dx. Notice we have an ln x right there, we have an x right there. That will work out. So we can just, oh, also don't forget to plug in your bounds. So ln b and ln 5. So now let's just plug in our new bounds and simplify into terms of u. So this will be ln b, a ln 5. So it would be 1 over u squared du. Now this is the same thing as saying limit as b approaches infinity. Oh, you can't forget the 5. As limit b approaches infinity of 5 integral ln b ln 5 u to the negative 2 du. Now we're gonna integrate this normally, and this we'll just add 1 to the numerator and divide by that new numerator. So it's equal to limit b approaches infinity 5 u, or we can just take that to 5. We can multiply a whole limit by 5 since it's just a constant. So we limit as b approaches infinity, u to the negative 1 over negative 1. We just simplify this down to negative 1 over u, with your new bounds, which is ln b, ln 5. Now this is equal to 5 limit b approaches infinity, 1 over ln b plus 1 over ln 5. Now ln b, the denominator becomes infinity and the numerator stays constant, therefore this whole thing right here will become 0. So this is 0 plus 5 over ln 5. The reason we have a 5 right here is because we had the 5 up front, and we can't forget about it, so that's why we multiplied this part right here by 5. And remember, if you get a number, it's not what the series converges to. It just means that the series does converge. So we can say series starting at 5 going on to infinity of 5. Wait, okay, yeah. 5 over k ln k squared converges according to integral test. Integral test. Box it. Green highlight for answer, purple highlight for question. And that's it. Thank you for watching.